feel the vibe.
All right, guys, thank you for tuning in to another online lesson here for Algebra 2. As we finished up the last target, we actually finished up the last section here that we had for exponential and logarithms. So we are going to go ahead and start a new unit. This unit is all going to be about systems of equations. And today we are going to focus on linear systems and two variables. These notes are basically going to be a complete review of what you did in Algebra 1. We're not really going to present anything new. We're just going to review some topics for systems of equations that we're going to need to be proficient at when we move forward. So let's go ahead and jump into the notes. If you have the option of printing the notes, you can go ahead and print them and follow along in that guided notes packet. If not, go ahead and just take some notes down on a separate sheet of paper. Remember, you guys will be able to use these for your quiz, so make sure you follow along with good notes through the examples. Let's start with the definition for a system of equations. So a system of equation is basically when we combine two or more equations for a given scenario. They have the same variables and we're looking for a common solution. So let's say that, for example, the school is having a play and they have 500 tickets that they need to sell, and there's children's tickets and there's adults tickets. And so they sell all 500. They sell 500 tickets. And let's say the children's tickets cost $3 and the adults tickets cost $5. We can combine the information that we know about children's tickets and adults tickets being our variables to create an equation. When they added together, they're going to be 500. And we could also create an equation to figure out about the revenue. If children's tickets cost 3, we would do 3 times x and add that to 5 times y for adults tickets to figure out the revenue. And so that would create two different equations based on the same variables. And we'd want to figure out how many tickets should we sell of each, essentially, for just an example. So if you look at problem number 1, we see some notation of a system of equations in both 1a and b. In problem 1, we're just verifying that the point is actually a solution to the system. So when we think about graphically, and we're going to do this here in a little bit, but let me just sketch out a visual. Something that we've been doing is we've been finding intersection points on graphs this year when dealing with word problems. And so if we think about two lines graphically, where they intersect, this point would be the solution for that system of equations, one that represents each line. And so what we're doing here in problem 1a is we're just verifying that the point that they gave us is actually the real solution where these two lines intersect. Now, they're not written in linear notation or normal y equals mx plus b, but that's okay. How we can verify or determine if it's going to be a solution is just take the point and substitute it into the equation. So if we take that first equation, 3 times the x value would be 3 plus 2. If we do 3 times 3, that is 9, plus 2, this equals 11. And so this checks out for our first problem. Now if I do the second equation, negative 5 times 3 plus 2. Negative 5 times 3 is negative 15, plus 2 is negative 13, and this checks out. So 3, 2, this coordinate pair is a solution. And we could also check this using the graphing calculator. So you could type in the computation that I have written out here. If you can't do that in your head, that's okay. You can type this into the calculator and see that this would be equal. And so we would have a solution here. In B, see if you can pause for B and see if the point 1/2 negative 1/3 is going to be a solution. Okay, so hopefully you figured out that this is not actually a solution. So if we check this again, we want to substitute. So the x value is 1/2. The y value is negative 1/3. And if you could do this in your head, that's great. I'll actually go ahead and show you this out on the calculator. So for this one, so 4 times 1/2 plus 15 times negative 1/3. This is going to equal negative 3, and so this equation actually does not equal. Now we could go ahead and type into the second one and see that it does not equal for the second equation as well, but all we need is 1. For it to be a solution, the point has to make both of these two equations equal. And so here in the first one, if we substitute it in, what that would say is -3 is equal to 7, and we know that that is not true. So 1/2 -1/3 is not a solution. So what we're looking for here when we find solutions to systems of equations, they can be written as points, that's okay, or they could be written as an x value and a y value. What we're looking for is an x and y value that makes both of the two equations equal. Now, there's three methods that we're going to use to find these solutions. The first one is graphically. So basically, we're going to graph the functions. Now, what we want to do to graph the functions, we're going to look at how to do this on the graphing calculator. If you have Desmos, you can do this on Desmos, and it works out pretty nicely. But you can also do it on the graphing calculator. It takes a little bit more work, but we'll go through the steps in the graphing calculator because that's going to be something that's available to you too at all times. So let's go ahead and take a look at 2a. If I want to solve this graphically, again, we said we were looking for the intersection points. In order to type it into my graphing calculator, I need y by itself. And so what I want to do here for this first equation is get y by itself. So that first equation, what I might do here is subtract 4x from both sides. So if I subtract 4x here and subtract 4x there, it's going to give me -3y equals 9 minus 4x. Or if you put -4x plus 9, that's okay as well. Then I would divide by a -3 and simplify where we can. So the first equation is y equals -3 plus 4 over 3x. And I can go ahead and type that into my calculator. -3 plus 4 divided by 3x. And I can do the same thing then for the second equation. So here I might add 2x to both sides first. So y equals -5 plus 2x, or 2x minus 5. And then go back to my graphing calculator and go ahead and retype that, or type that one in down at a separate line. So 2x minus 5, or -5 plus 2x, doesn't matter. Now I'm going to hit the zoom, and I'm going to hit the 6 button here just to make sure my window is on the standard window. And I can see where they cross. So what we need to find is the intersection key. Excuse me. Remember on your graphing calculator, the intersection key is by hitting second, and then go into the calculate menu, which is trace. And you can go down and select intersect. It'll say first curve, so just make sure you're on one of the lines, hit enter. It'll say second curve, make sure it's on the second line, hit enter. It'll ask you to guess, you don't need to worry about guessing, and there's our answers. X equals 3 and y equals 1 would be the solution to this system of equations. Now if you wrote that as 3, 1, that would also be okay. So again, what we want to do here is we want to get y by itself, then graph and find the intersection point. Let's go ahead and take a look at another example. Let's do b together. So in the numerator, or sorry, not the numerator, but in the equation listed first, here I might subtract 3x from both sides. That gets y by itself, so y equals 2 minus 3x. So I'm going to put that into my calculator. I'm going to clear out the ones that I had in there previously. So 2 minus 3x. Then in the denominator, the second equation, I want to get y by itself again here, so subtract 5x. So that gives me 3y equals 12 minus 5x. Now I need to get rid of the 3 in front of the y, so I divide by 3. Simplifying where I can, y equals 4 minus 5/3 x. So go ahead and type that in. And graph these. And there I can see an intersection, so hit second, trace, to get me to the intersect, or the calculate menu, go down and select intersect. For the first curve, you're on one of the lines, hit enter. It says second curve, you're on the other line, hit enter. And then when it guesses, you don't need to worry about guessing again, just hit enter. And so there's our solution. X equals -1.5, y equals 6.5. So there's a little work that we have to do here when we solve them graphically, because we have to get y equal to, or both equations set equal to y by itself, and then we can type the equations into the calculator and let the calculator do the harder computations for us. See if you can do the third one here. See if you can do C. So I'm going to go ahead and pause the video, come up with an answer for C, and then we will play and check the video. Okay, hopefully you had enough time there to get an answer. So let's go ahead and solve now for y. So here on this top equation, if I want to get y by itself, I would subtract 3x. So 2y equals 12 minus 3x. Then divide by 2. So y equals, sorry, divide everything by 2 here. Show that step. So y equals 6 minus 3 halves x. So I do want to go ahead and type that into the calculator. Again, if you wrote this as negative 3 halves x plus 6, if you wrote it in the format of y equals mx plus b, that's okay. If you're graphing it by hand, we might want to write it in that format, but our calculator does this format as well. On the second equation, I would subtract by x, so negative y equals 9 minus x, and then here I do need to make sure that y is positive, so I need to divide by negative 1. So y equals negative 9 plus x, or y equals x minus 9. As I graph those, I do see that intersection point. So second, trace, choose the fifth option. Enter on the first curve, on the second curve, and no need to guess. X is 6, y is negative 3. And there we have our solution. Okay, so graphically, it's not a lot of work. Rewrite the equation, set it equal to y, substitute that into the calculator, and then find that intersection point on the calculator. Now, there are some algebraic methods that we're going to use as well. The first one is substitution. So if you're a person who likes laid out steps for you, I have the 4 steps, and we're going to go through these 4 steps. You may want to take a moment to pause the video and record those 4 steps. We're going to go through them one by one in each of the 3 problems. The first problem, 3a. So in order to use substitution, we want to rewrite one of the equations for a given variable. Essentially, we want to get one of the variables by itself. Well, 3a, this is nice. Step number 1 is already done for us. The y is already by itself. So now we can go to step number 2, which is substitute that expression into the other equation. So what I want to do here is I want to take what y is equal, this expression x plus 2, and substitute it into y for the first equation. So remember, substituting is just replacing one variable or expression with another. So if I take that first equation and rewrite it, it would be 4x plus y, but now I'm getting rid of the y and substituting in x plus 2. And then it's equal to 4. This is an equation that I can solve. It's got one variable, so we can combine the two x's. 4x plus 4x plus x is 5x. And now I can go ahead and solve for x. Subtract by 2, so 5x equals 2, and then divide by 5. So x equals 5 halves, or if you wrote this down as, I wrote it as 2 over 5. Let's try that again. X equals 2 over 5, not 5 halves. So if you wrote this down as 0.4, that would be okay as well. Now that's the solution for x, but we want to figure out the solution for y. So now what we can do is we can take this x, the step number 4, and substitute it back into either of these 2 equations to solve for y. I'm going to use the second equation because this is where y is by itself. So I'm going to take y equals x and replace x now with 2/5 plus 2. So 2 is just 10/5, so y equals 12/5. If you wrote this as 2.4, that would be okay as well. So the substitution method is done by getting one variable by itself, then substituting that into the other equation, solving for a variable, and then repeating the process until you solve for both. Let's take a look at B. In B, it's not quite as easy because neither of these have a variable by itself. So let me go ahead and use the bottom equation here to get y by itself, because this isn't too hard. Well, what I would do here first to get y by itself is to move the 8x to the other side. So subtract 8x from both sides. So this would give me negative y equals 6 minus 8x. Then I would want to divide by negative 1, so y equals negative 6 plus 8x. Now again, once we get y by itself, we want to go back to the other equation and substitute it in. So I want to go ahead and replace this y right here with negative 6 plus 8x. So I'm going to take that first equation and rewrite it. 2x plus 5 times. Now remember, this is going to be multiplied by 5, so I need this in as a quantity, because I need to remember to distribute here when I simplify. So as I simplify, 2x minus 30 plus 40x equals 5. Combine my like terms, so 40x plus 2x is 42x minus 30 equals 5. Add 30 to both sides. 42x equals 35. Then finally, divide by 42. So x equals 35 over 42, which simplifies into 5/6. Now, real quick, if we do this in the calculator, if I do 35 divided by 42, I'm going to get a repeating decimal. So what I want to do is change that into a fraction. You can do that by hitting the math key and then enter for fraction. And there we have the exact answer. So we don't want to round this answer if we don't have to, and we don't have to here. Now, if I want to figure out y, I can take this x and put it back into that equation. So y equals negative 6 plus 8 times 5/6. And we can do that in the calculator. So negative 6 plus 8 times 5/6 gives me another decimal. I can turn that into a fraction, so y equals 2/3. So using the substitution method, getting getting y by itself, substituting that in, solving for x, and substituting that in to solve for y, I have my solution here. X is 5/6, y is 2/3. Again, if you want to write that as a coordinate pair for your solution, that's okay. Go ahead and see if you can pause the video and do C. So solve C using the substitution method. Hopefully you got an answer there for C. If you got x equals 4 and y equals negative 3, then you did this correctly. So let's go ahead and let's see how we got there. So what I would do here is I would use the bottom equation to get y by itself, because that's a simple step, one step. Y equals 17 minus 5x. Now I can take that 17 minus 5x and substitute that back into the first equation. So this would be 3x minus 4 times 17 minus 5x equals 24. So then I can distribute the negative 4. So negative 4 times 17 is negative 68. Negative 4 times negative 5x is positive 20. X, combine my like terms here, so sorry. 3x plus 20x is 23x minus 68 equal to 24. And I would add 68 to both sides of the equation, so 23x equals 92. Divide by 23 and find out that x is 4. So there's part of my solution. Now I can go back to any of these equations and substitute in the 4 for x to solve for y. I'm going to choose this equation right here because y is already by itself. And so if I want to substitute in the 4 to solve for y, y equals 17 minus 5 times 4, which you could type into your calculator and come up with negative 3. Now, one of the things we can do here is we can also check these answers to see if they're correct. You could graph the equations and see if they come up with the same intersection. Or you could do what we did in problem number 1. I could go back and I could put in my x values. So 3 times 4 and my y values, negative 4 times negative 3, and see if the equations are equal. It equals 24, so that's good for the first equation. So let me do 4 times the x, which is, sorry, 5 times the x, which is 4, plus the y, which is negative 3. That equals 17. It's good for the second equation. We know we have an answer there. So this first method is substitution. We primarily use substitution when it's pretty quick and easy for us to get one of the variables by itself, in this case y. Now if it's not,